Hi everyone. This video is going to be going over the procedures for graphing various types of charts in Excel that relate to the tasks that you have to complete in Lab 1. So as a review, going over our graphing pointers, remember that you never use a screenshot of your Excel graph in your document. You can just copy and paste it into your Word document for your lab write-up. So oftentimes when you paste into Word, your graph will link in the Excel file that you have the original graph in. And so if you make any changes in the Excel file, those changes will automatically be recorded in the Word document. That way, if you made a mistake, you have to go back, fix your graph, it's already automatically done and you don't have to remember to copy and repaste in your lab write-up. Oftentimes using a text box in Word and pasting your graph into that text box can be useful. I can leave that up to you guys if you want to do it or not. I'll show examples in the video a little bit later. But sometimes when you have multiple figures within one task, that text box kind of helps to organize things a little bit better. Always ensure that error bars represent your data. So oftentimes when you have error bars inserted initially, they will represent the standard deviation of your data set. This doesn't happen automatically though. Usually there will be a default value of 1, meaning that from the mean that is plotted, you will have plus 1 standard deviation and minus 1 standard deviation plotted on your chart, which isn't always going to be in the units that your data were collected. So we'll go over examples on how to make sure that your error bars represent your data. For number 3, make sure that you're minimizing empty space on your graph. So if there's a lot of white space, say in a scatter plot, you want to adjust your axes values such that you kind of enlarge the content that is being graphed and you're minimizing how much white space is around that content. Graph titles should reflect the overall question of the experiment and a relationship that is being demonstrated. So I'll give you several examples of some graph titles that would be acceptable. Graph titles can be different from figure titles. So for us, graph titles will be more related to figure titles. Sometimes your graph titles or your chart titles will need to be like figure A or figure B if there are multiple figures or multiple graphs within a certain figure that you're plotting. So we'll have several examples of this, but mainly you just want to remember that there should not be a one-word description of your graph, just because that doesn't really tell us a whole lot about what is inside the graph. The only exception to this would be if you have like chart A, chart B, that type of thing. But figure title should be relatively descriptive of what is in the chart. Always double check to make sure that your Y and X axis units and labels match and are appropriate. I've seen in past semesters students will automatically think that they've plotted things correctly and maybe they don't, and it would have been a really easy fix if they looked at the values that were in the axes, and your values should relatively match the data that you're plotting. So always double check to make sure that you've got your X and Y axes sorted out in the correct order. For continuous variables, on the x-axis, they should usually start at 0 and progress in reasonable increments. So reasonable being if you have a range of data values from 0 to 100, you probably don't want to plot your x-axis by units of 1 because it could get very crowded, the numbers start running into each other, there's just not enough room. So that's kind of left up to your discretion. You could break it down into increments of 10 or 20, right? Whatever is more aesthetically pleasing to the eye and easy to read. The only exception to the starting at 0 would be if you need to minimize the empty space or the white space in your graph, in which case you could always adjust the starting and ending values in your axes. There's a couple of other hints that relate to adjusting the x-axis that I'll let you guys read through. For pointer number 7, we want to make sure that we're minimizing the use of grid lines. So Excel will automatically put vertical and horizontal grid lines. These are different than the axes lines that run next to your x and y axis values. So you can easily take these grid lines out by clicking on them and then just choosing delete or backspace. But they kind of put a little bit more noise into your graph and make it hard to read sometimes. There are other times where maybe you want lines, especially if you have a lot of different data points or very small intervals that are listed in a particular axis. So minimizing use of grid lines is kind of our rule of thumb in this course, but surely if you were making graphs for some other project or something, your use of grid lines is completely up to you. For your axes labels, they should never be covered by data lines or points. Lines meaning the axes. We'll have an example of this, so I'll show you how you can make those adjustments. If applicable, the description or notes section of your graph should accurately and concisely describe the graph contents that are being displayed. So your figure title should be generally like a very short, brief description of what's in the graph, right? So if we were looking at joint angles over time or joint angles in walking, that type of thing. The actual description or notes section of the graph should be a little bit more or have more content to it, in which you might summarize what the graph represents in terms of the data that you collected. So if someone was walking at a preferred speed, or if they were if we have a certain phase of the gait cycle, say we're only looking at the swing phase, and we're only looking at swing of the dominant leg, that type of thing. Okay, sometimes in the description section you might also indicate what certain values in the chart mean, or if you have a multi-chart figure, you might have separate descriptions for chart A versus chart B. So rule of thumb is that your figure title should be fairly brief, but accurately describe what is in your chart, and then the description is kind of where you get to elaborate on the contents a little bit more. Be sure to edit line or marker thickness and color to improve clarity and contrast. Okay, so if you're having trouble identifying what you're looking at, somebody else will likely have the same issue. When making and editing graphs in Word, just be sure to adjust the size and position of the graphs. Sometimes when you copy and paste from Excel to Word, the graphs will either balloon up and zoom in really tight, and then all of your contents get kind of messed up. So make sure that you have appropriate font sizes, appropriate font styles, that type of thing is what this is kind of referring to. Last pointer is to never submit your lab reports as a Word document. You're going to want to convert your lab documents to a PDF file type. The only caveat with this is that, especially when you use text boxes do not conform to the margins of your document. So if you convert your Word document or your write-up which should be done in Word, to a PDF, a lot of times contents will shift and then get cut off, which isn't great because that affects your grade in the class. So most of you, I feel like, might know how to save as a PDF from a Word document, but if not, when you do a save as, so you can do this by pressing Shift Control S or Shift Command S, depending on the type of computer you're on. You can choose the area you want to save it as, and then where it says file format, you can just convert it to a PDF. And then open that, double check, make sure everything is visible, none of your items have shifted, and then you can go on about your day. But in general, for formatting, this is what your graphs should look like, right? So data with no grid lines. Sometimes you'll have a chart title if applicable. Your figure information should be up here. If you have a multi-series data, which we'll have some examples of, you'll usually want to include some type of legend that represents what each series looks like. So if you're doing a bar graph, do you have a certain color for each bar or each series? Do you have a certain pattern? Sometimes people use a grayscale theme, and they have like a solid versus an open versus a bar that has diagonal lines in it, right? So the legend just helps orient the reader so they know what the data is actually representing. But usually we will put the legend either on the right or the bottom of the graph. It kind of just depends on how the legend affects the actual content. Sometimes if it's on the right, it'll squish the data. So that's kind of up to you, but if a legend is present, it should be either on the right or to the bottom. You'll want to make sure you have the appropriate axis labels and units. This is in addition to the actual correct values that would be located on the horizontal and vertical axes. And then you have your description area. I kind of have a bogus type description down here, just saying and how you might format your description if you have two graphs. So in the case where we have, figure 1 and there's a part A and a part B, you would have a description for part A as well as part B, especially if they show different things. For the instructions, we're going to split up into small groups, which, this is kind of an afterthought video from lab, so if you're just referencing this on your own, then that's cool. If we happen to have done this lab virtually, then welcome. You're just doing this by yourself. But I think it's important that you try to figure things out on your own. It can be tedious and it takes longer, but you actually end up retaining information better when you look it up yourself. So I try to give you guys as much information as possible because I know Excel can be kind of a daunting thing to learn. It's complicated. There's a lot of things that are not intuitive by nature, and in previous classes I feel like most people just assume that students understand how to use Excel when it is a very crazy tool, and it's not straightforward for the most part, especially if you want to do crazier things. So I'll try to give you as much information as possible, but if for some reason there is a blank that you're drawing, or what I said makes no sense at all, or it's not working on your end because you're in a different operating system or a different version of Excel, try Googling, okay? Usually when you Google, you'll want to include what you're looking for, the operating system that you're on, so if you put like Excel Mac or Excel Windows, and then you also want to include the version of Excel that you're using, because when they update the programs, things are in different locations, they look different, they're named different things. So an example would be like how to create a line graph in Excel 365 on Mac. Right? So including those 3 simple things can get you a really long way on the internet, and honestly, I've learned most of Excel by looking stuff up. So it is tedious, but it does help. In terms of graphing, you guys are going to be responsible for creating 4 different graphs, each of which will be used throughout this semester on different data sets that you'll be collecting in labs to come. So it's really important that you understand how to make these graphs this week, and then you kind of just keep building on your skills later in the semester. But each figure has a description kind of what was collected, and then instructions on the type of graph that you should be plotting. Some of the graphs involve performing certain calculations within Excel, or adding specific chart elements, which we'll go over in some sample data. But this is the general layout of the figures that you're going to be making. So for figure 1, you're looking at reflex and reaction time methods. So basically, this is what the data look like. We have subjects 1 through 10, their reflex times, and then we can look at their simple reaction time versus a complex reaction time. Really, the main difference between the two of these is just how the reaction time task is set up. The number of choices that a person has and the number of correct responses that are associated with those choices given a certain stimulus. So I've created a similar set of data that we can kind of practice with, but essentially the procedures are pretty much the same. So this is actually data that I collected for a standing long jump study. We had a baseline jump where we just told people, like, jump as far as you can. And then we had consecutive jumps where we gave individuals certain attentional focus cues. So either they had no cue prior, they were separated in 2 different ways. There was a pre-cue, which we gave to an individual before they approached a force plate to take their jump, and then we would give them a cue immediately before they jumped. So 2 cues that were given prior to, or 2 cueing periods that were given prior to the actual jump. One being that they had no instructions, then an external focus of attention immediately before the jump. No cue prior to approaching the force plate, then an internal focus of attention cue before performing the jump. And then we had internal, external, external, external. Okay. Those aren't necessarily important to you, but just so you know what these labels are indicating. So if we wanted to create a bar graph of this data, we don't necessarily create the bar graph off of all of the data at once. Typically what we're interested in when we have bar graphs is looking at group averages. So you will notice in our Lab 1 data, we have this small table that we've created at the bottom where we're indicating a mean and standard deviation. Basically, we're going to do the exact same thing here, where we have a row for the mean and a row for the standard deviation. And then for the labels for each of these groups, it's pretty much just going to be these guys. So for ease of reading, I'll just copy and paste those down here. And then we'll put an extra row in there just to break up our stuff a little bit better. Okay, so when we're calculating a mean or an average, we can use functions within Excel to accomplish these pretty quickly. So I'm going to use the average function. You literally just type average. Also, you'll notice as you type, you'll find functions that pop up that include what you're typing. Okay. And then the syntax for this particular function is just inserting all of the numbers that you want to average. So in this case, we want baseline all the way from subject 1 to subject 31. There's a couple ways that you can highlight data. You can either click and drag, right, and identify various ranges, or if you have a particularly long set of data, or something kind of similar to this, which is more of a medium length, you can click on the first data point, hold the Shift key, click on the last data point. Alternatively, you can click on the first data point and then click Shift, Command, or Control, depending on the type of computer you're on, and then the down arrow, and that will automatically highlight your range. That one most of the time works. Sometimes it'll pop you down to the end of the spreadsheet, so if that ever happens, just press Shift Command and the up arrow and it'll reverse your keystrokes. So that's happened to me several times, and then before you know it, you're down to like cell 10,000, which is not what we want all the time. So anyways, we highlight the range of cells that we're interested in calculating the average for, and you can press enter. For standard deviation, we put equals STDEV. And it's pretty much the same thing. Highlight the range of cells you want the standard deviation for and press enter. Now the cool thing about Excel, I'm quickly just going to adjust the number of decimals that are presented to 2. The cool thing about Excel is that you only need to really put information into cells one time. So I have these, if I double click on the cell, right, you can see I've got this function attached to a certain range of cells. If I wanted to copy these functions to these other groups that I collected in my data, you'll notice that as I hover over this little green square in the bottom, my cursor changes from a white plus sign to a black plus sign. Once it turns black, all you have to do is click and drag, and that will copy your function sideways or across your spreadsheet, meaning that the references that were originally here, this B2 to B32, as you copy sideways, the cell range will shift the number of columns that you are spanning across. So, for example, to get to my no IF condition, I went 2 columns over, therefore my range shifted to 2 columns over. So that's kind of a fun little trick that might be useful to you if you're working in Excel in the future. To get a bar graph, we're going to highlight our data labels as well as our averages that we just calculated. We then go to Insert, and then in the chart area, you will see a bunch of different charts that you can choose from. For this particular example, we're doing a bar chart, and you can just use the regular clustered column. And then we have our chart pop up, which is great. Okay. You can see I have my data labels listed already at the bottom of each bar that they respectively go to. If you notice that you have numbers 1 through 5 down here, you likely did not highlight your data labels with your bar. So I'll show you what that looks like. If you only highlighted your averages, you might get something that looks like this. If you are in this boat, what you can do is either go to Select Data, which is in the Chart Design tab, or you can right-click on the graph, and Select Data is another option in your drop-down menu. And there should be an option, I know this will look different between Mac and Windows, but you can click on your horizontal category access labels and then just select the data that represent your labels. And then you can see it'll auto-populate in here. So if you ever make a mistake, Select Data is usually a way that you can change that mistake. For this particular example, I'm only making well, technically, this example is comparing to our figure 1 instructions. So for graph A, for figure 1 instructions, you're making a graph that reflects the means of each of your conditions. And then graph B is going to essentially repeat the graphing process for the group means, but instead of having just one series or just the group means in there, you're also going to compare a single subject from the data set. Doesn't matter what subject, you just pick one and you're good to go. But you'll have two series within the bar graph. So that's why we call it a column or bar graph with a series. So for this example, let's just call this chart A. We can move that over to the corner. For a figure title example, I'm just going to stick it in here. But let's say this was figure 1, and we're looking at, maybe the effects of different cues on standing long jump performance. Okay, so not super explicit in terms of what we actually did or collected, but it does show, right, different cues, right, it is what separates our groups from each other, and what we're measuring is the long jump distance. So this would be an acceptable figure title. In this case, because we have two different charts that we're making, chart A versus chart B would be acceptable chart titles that you could use. We also need to make sure that we have the appropriate axis labels. Okay, so again, if you go to chart design, you can add chart elements over here. If you're on a Windows computer, usually there will be a green plus sign. That is the add chart elements like drop down menu, so that's another option if you have a Windows computer. Well, we're going to add axes titles, primary horizontal and primary vertical. Okay. For this, we could just say jump conditions. That would be fine if you wanted to say queuing conditions, whatever. Okay, but they match what the x-axis represents. And then for the vertical axis or the y-axis, this is representative of jump distance in centimeters. So usually you say what the variable is, as well as the units of the variable. You only put units if you have numerical values that are representing your data. Okay, so these would be acceptable types of axes labels. We then need to double check for our numerical values over here. If we double click on any chart element, there will be a formatting toolbar that pops up on the side. So you can see we can adjust the axis bounds and the units by which they are separated. I kind of think that 2 is a little bit close, so I'll show you what it looks like if we changed this to 5. Right, and that just creates a little bit more white space between our data points, makes it a little bit easier to look at. You'll see these horizontal lines here. Again, we want to make sure we get rid of grid lines for this class, so if you click on any one of these grid lines, you can delete them easily by pressing the backspace key on your keyboard. And the last thing I wanted to show you with the axis is that for the number, you can choose how many decimal places are listed. So oftentimes when we've got data that are inserted as like whole numbers within the axis, we don't necessarily need all of the zeros. So if I want 0 decimal places, I can do that, and then my jump distances are listed as whole numbers, which is a little bit easier to look at. Less noise, I suppose. Okay. The other thing that we want to add is error bars to kind of show the different standard deviations of each of our jumps. So to do that, we go to Add Chart Element, and then we choose Error Bars. For now, you just click on Standard Deviation, and you'll see that all of these lines are uniform, which is not what they're supposed to be. So if you click on the error bars, or actually double click on the error bars, you'll have the option to format them. When we talk about standard deviation, we've got basically the mean, and we can go plus that standard deviation value or minus the standard deviation value. So standard deviation really just tells us how spread out are our data from the mean. And we can either show both plus and minus, we can do just minus, we can do just plus. So kind of give you an idea of what those look like. For this class, if you just want to do plus, that's fine. Sometimes if you do both, it'll mess up the bars, especially if you have a really large standard deviation. And then you can also choose if you want a cap or no cap, meaning there's just a little line at the top of the standard deviation line. In the error amount, we want to make these custom values, and then we need to specify what values we're using. Since we're only doing a plus for our direction, we only need to insert a positive error value. So to do this, we can click on our chart select icon, and then go down to our standard deviations and press enter. This will then adjust our standard deviations to match So I'm not sure why this did this, but you can see that the vertical axis was kind of jacked up after we added the error bars. To easily fix this, you can just double click on your vertical axis, go to the 3-bar option, and it looks like what happened is our major units ended up skewing with our minimum and maximum values because we added basically 45-ish units on top of what our original maximum was. A very easy way to fix this is to just change the interval by which you're separating your values, and that will make it more legible again. Another part of our instructions is if we wanted to graph our group averages compared to a single subject. So in your data set, you have a choice between subjects 1 through 10. I don't really care which subject you choose, as long as the format of your graph is correct. So an example of how we might do this in our data set, let's say I want to look at subject 12 and their comparison to our mean values for all subjects put together. So I can just highlight these two sections, and the way that I did that is you highlight the subject of interest, and then if you're on a Mac, you would press and hold Command. If you're on a Windows computer, you press and hold Control, and then you can choose another selection of cells. From there, I can insert a bar graph, and you'll notice I now have 2 series. Okay. Again, if you forget to identify a horizontal axis label, when you have split data, it sometimes is a little bit more difficult, so I'm just going to do it our secondary way here. And then also in the select data while we're here, we can label what our series are. So if we look at our mean compared to our subject, for the baseline jump, we can see that the subject's jump distance was less than the mean. So that's how you know which series is which. right? The smaller bar would be representative of subject 12, which in this case is series 1. So when we select our data, we can name the series to, say, subject 12. And then our series 2, or our orange bars, are going to be representative of the group averages. Okay. Once we make all of those adjustments, we can say our chart title is figure B, for example. And then you would want to make sure that your titles are present as appropriate. Okay, so basically listing them exactly the same as you would in the first chart. We don't need error bars for this one just because in order to do error bars you need a standard deviation, and for a single subject we can't make a standard deviation. So for this one we can just be okay with making sure our extraneous chart elements are gone, and we should be good to go. Okay. If you're putting this in a Word document, just to give you an example, I'll create a new document. There's a couple of different ways that you can insert your figures. So we could do something like our figure 1. Actually, this should be in a sentence case. So I'll change, well, should change. Anyways, I'm not going to worry about that for now. A couple ways you could do this is you can either copy and paste your graph directly into Word, and then underneath you basically just put description or notes or something like that, and then you would say figure A represents ... figure B represents ... and you just put a description of what each chart has. The other method that you can use if you're wanting to kind of make sure that all of your chart elements stay together is to use a text box. So to give you an example, on this second page, you can insert a text box. Right? You kind of start at a general size, paste the content you want to be in there, and then you can adjust the text box size to match the content that you have. This can be useful if you move outside of margins. You can see the boundaries of the text box can be anywhere on the page. So sometimes this is helpful, especially if you have multi-figure graphs or multi-graph figures. But the issue sometimes is that when you convert to a PDF, things will get shifted. So you have a couple of options on how you can insert your graphs into your document. Honestly, as long as they are the correct graphs are listed underneath an appropriate figure title, and you have a description, if a description is needed, you should get full points. Just make sure your graphs are not jumbled from task to task. Okay, so that's how we make bar graphs. Honestly, that's probably the one that's going to take the longest because I was introducing you to a lot of other Excel type concepts as well. Moving on to figure 2. In your data set, you're going to be looking at center of pressure while a person was in quiet stance on a forced plate. This extra information in terms of how long the data was recorded, at what frequency, etc., is kind of just extra. Make sure, I've had students do this last semester where they just copied this section and put it as the description for their graph. That is a no-no. Okay. A big part of being in our field is being able to reword things or summarize information in our own words or condense information down into our own words. So if you copy and paste the descriptions of each data set directly into the description section, you will get 0 points for the description. Just a heads up. Okay. But for this, you're going to have some kinetic data that you'll be plotting specifically in a scatter plot. Okay. So in this particular example, we're using scatter plots with smooth lines. There are different types of scatter plots you can use, but please make sure that you read the instructions and input the appropriate chart type. This is our example for the purposes of running you through some procedures. So we've got right ground reaction forces in the x and y directions, and then we also have left foot ground reaction forces in the x and y directions. What you'll want to do for this particular example is create two different graphs, one that shows the right foot, the other that shows the left foot. And we're interested in seeing how our forces compare to each other, okay, using one set of pressures on one axis and the other on the y. So x should go on the x, y should go on the y. For your guys' data, it'll be fairly similar, right? Instead of looking from foot to foot, you're going to be looking at two different participants. So participant 1, center of pressure, x direction forces are on the x-axis, y direction forces are on the y-axis. Okay. So similar to our bar graph, we can start by highlighting our data labels. I'm going to use my shift command down arrow because this is a longer data set. A fun little tip is to scroll back to the top of your graph, or back to the top of the spreadsheet when you have a longer data set. Wherever you start to click on the insert process, that is where the graph will insert on your spreadsheet. And I've had a lot of students in the past where they inserted at the bottom of the spreadsheet and then they couldn't find their graph. So scroll back to the top, then start your insert process. The scatter plot icon is right here with a bunch of dots. Okay, you can see that we can insert just dots, we can insert lines with markers, smooth lines, you kind of get the picture. Okay, so the instructions for figure 2 are going to be scatter with smooth lines, so that's what I'm going to show you here. Okay, the first thing I'm going to do in this graph is get rid of all of the grid lines. Okay, and then I need to set up my axes. Pay attention in our the actual ones you're going to be graded on. I've identified certain ranges for you to adjust your axes to, so just make sure you do that appropriately. And you adjust x and y axes by double clicking on the axis of interest, and then you can change the minimums and maximums accordingly. Okay. For my chart title, I'm just going to put A because this is a 2-chart process, right? So in this case, maybe we're looking at figure 2, which this isn't going to be your figure 2, but for the sake of whatever, you know. Maybe we're interested in looking at the center of pressure in the right versus left foot. Right foot versus left foot. That would be better English. Okay. And so A would be COP in the right foot. You could either put figure A, you could put right foot COP as the chart title. Remember that you do have a description area, so if you copied and pasted your graphs into your Word document and you wanted to specify in the description section that figure 2A is the right foot, figure 2B is the left foot, either one works. Okay. You'll notice that our y-axis is going through our data. This is one of our no-no graphing pointers that we have listed. So to fix this, all you have to do is double click on the y-axis. And then if you scroll down to, not tick marks, I meant to click on labels, you can see the label position is next to the axis. Okay. If you choose high, right, that'll move it to the right. If you choose low, it'll move it to the left. In my opinion, either one is fine by me as long as it's not down the center of the graph. The actual axis line will have to stay at 0, so don't necessarily worry about the line going through the middle. We just don't want the labels going through the middle, because then, as you could see, if we kept it next to the axis, it becomes difficult to read the values that belong with this particular ground reaction force. The other thing we can do as for right now is you can see there's a lot of white space down here. So I'm just going to ballpark and say that 250 should be our minimum. You can see that kind of expands stuff a little bit more in our graphing space. And this would be more or less acceptable. Okay. We do need to add axes labels. So I'll add a vertical and a horizontal. This will be our ground reaction force in the x direction. Our force is going to be in newtons, as force generally is represented. And then we have our y direction ground reaction forces also in newtons. Okay. So similarly, you could do the exact same procedures with the left foot. You get a similar-ish looking graph, and now you have two figures or two graphs that you can paste into your write-up. Remember that these are sample data, so you're not turning these in, you're just turning in the actual figures that you will do on your own. For figure 3, in your lab, this is going to be looking specifically at joint angles during a walking trial, specifically during a stance phase of the gait pattern. So the data for that look like this. Okay, you have ankle, knee, and hip. For my example, I am using also ankle, knee, and hip angles, but instead of a walking trial, this is from the long jump study that I conducted. Okay, so I think it is in lab 3 or 4. When we collect data using the BioPack in class, you'll be given a similar layout where you have frame numbers, but not necessarily a span of time. You'll know the total time that it takes to complete a certain trial from the BioPack collection, but it's not, it doesn't get exported in your Excel format. So in this particular example, not related to what you would have to do in this example, we just have to create a time series. So this will be applicable in future weeks. So I just figured I might as well show you now. The total trial time for this long jump was 0.93 seconds. So in order to figure out how time is progressing per frame, right, or how many seconds per frame we have, we need to know what the frame rate is. So that would mean how many frames are there in a second based on the total time that we have. So in order to figure this out, we need to know the number of frames that exist in this particular trial, which we can figure out by using a count function. Basically, all this does is it tells you how many cells have values in them, which is pretty cool. Okay, so I can count and then divide by the total trial time. So that will tell me how many frames there are per second. And then to get how many seconds there are per frame so that I can create my time series, I just do the or like 1 second divided by the frame rate, which is 245. Okay. So then I know that for each frame, my time should be increasing by 0.004. Assuming that my time starts at 0, I can then create a kind of a self-populating calculation that says take the preceding time and then add our seconds per frame. Now I'm going to copy this function downwards into the entire data set. So what I want to do is add a $sign in front of the 5. That will freeze this cell reference so that as I copy downwards, this cell also does not go down. So I should press enter. And then another nifty trick to copy something, instead of clicking and dragging all the way down, I can just double click when the cursor turns the black plus sign. And if I go all the way down to the bottom of my data, I should be relatively ending at 0.93. Crazy! Okay, so after we have our time series, in your data set that you'll be doing, you have a percent stance phase, so you don't need to create a time series. Your X labels should be from 0 to 100. But what we're going to do here is I'm going to say my angles, and I want those to be plotted in a line graph. So again, I go to Insert, just choose a regular line graph, and then we can see our values pop up here. 3 different series, each color, right, represents a different joint. My neat angles, you'll know, notice are negative, okay, because I didn't switch them into positive values, but generally this is the pattern that we would see in the long jump. Per usual, as we did in the other graphs, you'll want to add in your horizontal and vertical axes labels, and then make sure that your actual values of your axes are not crossing the data. So again, because we have negative values, there is a 0 that goes through our y variable. So similarly to how we moved the vertical axis in the previous scatter plot example, when we double click on the x-axis, we can change the position of the labels. I'm going to do low, that'll move them to the bottom. Okay. Because I have a specific time series that I calculated, these x values need to be input. So you'll notice they go from 1 to 200 something, right? And that's not necessarily accurate with the time series that I've identified. So to change this, we can go to Select Data and then identify our horizontal axes labels, and then press OK. And that will change our time series accordingly. Now, because this is number by number basis, they're going to kind of smush themselves, and there actually is not a way to change this that I know of. So these being turned sideways and smushed together is generally okay. For a chart title, something that would be appropriate for this graph would be maybe, well, we actually don't need a chart title for this one. We can just replace it with a figure title if we wanted to, since we're only making one graph. So let's say this is our pseudo figure 3, and we're looking at lower extremity joint angles in a standing long jump. Okay. In your description, you might say what positive and negative values indicate. I don't know if you guys actually know how to tell, but let's say that we were looking at the right leg. We're in an x-axis, meaning our axis runs medial to lateral, so these are sagittal plane movements. So in this case, positive values for my ankle, which would actually be the blue line here, would be considered dorsiflexion. My gray line, which is my hip angle, positive values are hip flexion. And then for my knee, negative values are knee flexion. Okay. The opposites of those, if they dip down into negative and or positive, would just be right extension or plantar flexion, that type of thing. So the y-axis would represent time in seconds because we had created a time series. For you guys, it would be the percent of the stance phase. And my x-axis would be joint angles in degrees. Okay. Fun fact, if you press Option or Alt and 0, that'll give you the degree symbol. Or you can write DEG, also acceptable. Okay, and then just make sure you have your legend somewhere on the graph. Final check, we need to remove any other grid lines. And that would be how you create a line graph. For figure 4, in your write-up, you will be creating what we call a dual y-axis graph, where we have force on one y-axis and EMG on another axis. So I will move to my examples here. Your guys's will look like this. So you have a ground reaction force on one end, and then EMG on the other end. Okay. In this situation, particularly for your guys' example, let me find it again. Here we go. What you guys are doing is you're going to create a time series for the x variable, given that the total time for the jump trial was 93 seconds. So in your particular data set, you would insert a time series. Okay. And actually, this would be the exact same time series that we just calculated in this example. So you can use the same procedures, or if you saved your sample data, you can actually copy and paste that time series into this example to get your appropriate graphing set up. And then in the instructions, I specify which variable is the x, in this case it's time, and then your two y variables would be ground reaction force and the EMG signal. So for our example in here, we're interested in looking at force as a y, or not a y, an x variable, and then maybe we're interested in seeing how our EMG signals differ based on the amount of force that has been produced in the jump. So what we can do with this, and just so you know, we're doing scatter plots with smooth lines or a line graph. Both should give you the same image, but just know you have some options here. Okay. I'm going to scroll this way because that's a lot faster. I'm going to insert some smooth lines here. And it looks crazy at first. I understand that. Okay. But you'll notice that the force, or the first column that you highlight, has automatically been inserted as your horizontal axis. So if I double click here and go to my axis options, these force values from negative 200 to 1000 should, for the most part, match up with the data values you see in this first column. And I clicked out of the graph, so now I can't see those values anymore. But that should have kind of automatically been input correctly if it's the first column. So the same thing will go for your guys' data. If time is the first column, it should automatically go in as the X label. The fun part now is figuring out where or which is your biceps versus rectus femoris muscles. Luckily, we've got a legend here, but both of these are going to have a different range of values. So the way that we can change this, if you click on the orange set of data, so I clicked on rectus femoris, you can see it's highlighted here, so that's one way you can confirm you clicked on the appropriate series. You'll see that there's an option to plot the series on the primary axis or the secondary axis. The primary axis is to the left of the graph, the secondary axis is to the right. So we're going to put the rectus femoris on the secondary axis, and you will now see that the label ranges, or the value ranges for the rectus femoris are associated with its actual values now, versus our blue axis, which is on the primary axis here. So I'm going to get rid of our extra grid lines, and we're going to adjust our force because we don't actually go into any negative force. I want to adjust the y-axis to reflect that we want to start at 0, which would be more appropriate for our data set. Okay. So then from here, what we can do is add our axes titles. So we have a primary horizontal axis, which is representative of our force. So this is technically a ground reaction force in the z direction, again in newtons. We also can add a primary vertical as well as a secondary vertical axes labels. Remember, we said that our biceps femoris, right, you can always double check here, this blue line represents the primary axis on the left. So we could say BF EMG activity, this EMG is in millivolts, just so you know. Our secondary axis would be our RF EMG activity, also in millivolts. And then again, because this is just a standalone graph, we can just take the chart title out and make a figure title that represents what's in the graph. Okay, so you could say something like force versus quadricep and hamstring activity in a standing long jump, something of the sorts. The last thing I want to change is my y-axes, just orienting them to 0 because our values don't really dip past 0. And that will help kind of minimize how much white space we have, as well as any confusion that might come about with where the axes are crossing each other. Okay. So that's an example of how you can create a dual y-axis plot. Again, if you chose to do a line graph instead of a scatter plot, you should relatively get similar results. This is a bit messier than what you will see in this particular example, so just keep that in mind. For your Turnitin submission, just to reiterate from what we discussed in class, if we did have class, you're going to just copy and paste this entire section onto a new Word document. And then if you want to number your graphs, you can. Highlighting them as figure 1, 2, 3, and 4 is just as good. Okay, but you're going to format them. If there's 2 figures or 2 charts within the figure, make sure that you label them as such. For this one, I did specify we are going to do error bars on group data only. So let me just show you that really quick. If you did want to add error bars to a certain series, all you have to do is click on the a bar or series of interest. So if we're doing group averages, we have to click on the orange series, and then you can insert error bars for that particular grouping. And then we would change the actual values of the error bars by doing the custom stuff with the standard deviation for the group. I have some grading criteria that kind of generally gives an idea of how I assign points to different graphing elements. There are opportunities for partial credit, so if you make a mistake on a vertical axis, let's say that your values are not correct, or you're missing the units of measurement if there should be units of measurement there. Maybe your label isn't appropriate, or you got your X and Y labels mixed up. Usually for little things like that, I'll take off about a half a point. But in general, this is how your points will be allocated based on the components that should be included in each graph. So when you actually review your Turnitin submission, you should be able to view any feedback as well as sample answers that would have been acceptable. And obviously, if that feedback doesn't make sense, please reach out and ask me for any help. I'm happy to answer any of your questions. I know, again, Excel can be a little bit intimidating, but we are going to be using it quite a lot throughout the semester, so hopefully this was a nice introduction to help you become a little bit more comfortable with things that you can do in the program.